Hello, I'm Madhumithra. Today, I will walk you through the topic of trigonometry and parallax, measuring the unseen in astronomy and beyond. We're going to look into the introduction of trigonometry. What is trigonometry? It is a branch of mathematics that studies the relationships between the sides and the angles of a triangle. It's primarily concerned with right-angled triangle and how their angles relate to the side lines. The primary focus is on understanding how the angles of a triangle are connected to its sides. Functions like cosine, sine, and tangent help describe the relationship between angles and side length. We will look into it now. Sine. Sine is defined as the ratio of side opposite the angle to the hypotenuse. Cosine, denoted as cos, defined as the ratio of the adjacent leg to the hypotenuse. Tangent. Tangent defined as the ratio of opposite leg to the adjacent leg. Now, I'm going to take you through the history of trigonometry. Trigonometry has a long history that dates back to ancient civilization like Egypt and Babylon, where early forms of geometry were used for practical purposes. Greek astronomers like Hipparchus and Ptolemy took this further by creating the first trigonometric tables to help with studying the stars and planets. Indian mathematicians, including Aryabhatta and Brahmagupta, introduced the concept of sine and cosine, which were later adopted and expanded by scholars in the Islamic world. In the European Renaissance, Regiomontanus, often called the father of trigonometry, helped systematize these ideas, making them central to fields like astronomy and navigation. Over time, trigonometry became a key part of mathematics, with applications in physics, engineering, and even modern technology. Measuring the unmeasurable. When we look into real world scenarios, sometimes it's impossible or impractical to directly measure distance or angles, especially when objects are too far, too tall, or too difficult to reach. Imagine trying to measure the height of a mountain or the distance to the distant star. It's simply not feasible to climb the mountain or travel to the vast distance to the star for a direct measurement. Hence, we need trigonometry to solve this mystery. How trigonometry helps. Trigonometry provides a way to measure unknown distance and angles through indirect methods. By using known distance or angles and applying trigonometric functions such as sine, cosine, or tangent, we can calculate the missing values. The angles are evaluated by parallax shift of the object, hence known as parallax angle, which is denoted by small p. The distance is measured by the equation d equals cot p, where d is the distance and r is referred to the radius of the Earth's orbit. We will explore this concept further in subsequent slides. Let me give you a small example using trigonometry to measure distance. Imagine you are an astronomer trying to measure the distance to the nearby star. You can't travel to the star, so instead you measure the angle of the star from two different points in the Earth's orbit. This method is known as stellar parallax. Step 1. From the two different points on Earth's orbit, you measure the angle between the star and the Earth's two observation points. Step 2. Using this angle and knowing the distance between the two observation points, which is the diameter of the Earth's orbit, you can apply trigonometry to calculate the star's distance. As we know by now in astronomy, trigonometry helps measure distances to stars and planets using parallax. Interesting. Then what is meant by principle of parallax? Here comes the principle of parallax. The parallax directly involves trigonometry. Parallax is the observed displacement of an object caused by the change of the observer's point of view. It is a irreplaceable tool for calculating distance of faraway stars. The principle is used to measure the distance to nearby stars. By observing a star from two positions on Earth's orbit, 6 months apart, astronomers can calculate the star's distance based on the parallax angle. The larger the parallax angle, the closer the star is to the Earth. Formula for distance using parallax. D is equal to 1 by p, where d is the distance to the star and p is the parallax angle. Is trigonometry and principle of parallax only used in astronomy? The answer is no. It is widely used in various fields. Here are a few applications of trigonometry and parallax. It is used for 3D stereoscopic imaging and photography, and then robotic and computer vision, virtual reality and augmented reality, and also in architecture, and engineering. In summary, both trigonometry and the principle of parallax have broad application in science, engineering, astronomy, navigation, architecture, and many other fields, helping professionals calculate distance, angles, and positions in situations where direct measurement is difficult or impossible. And that's all for today. Thank you for listening. Have a great day.